decaying matter. And carbon dioxide is given out during our respiration, but the major emission source of carbon dioxide is combustion. This includes industrial combustion, vehicular combustion, and others. Nitrous oxide is more popularly known as laughing gas. Nitrous oxide, actually, when we inhale it, it gives us a delirium experience. So, hence the name laughing gas. Nitrous oxide is given out more by vehicular emissions because of the petroleum substances used in it, and also in complete combustions. Ozone is a byproduct of nitrogen dioxide given out by vehicular emissions. Ozone is actually a secondary pollutant and a secondary gas. This is not produced by humans or anthropogenic activities. Anthropogenic activities means man-made activities. Okay. Ozone, the major source of ozone is because of nitrogen dioxide getting into atmosphere, NO2 plus NO. These two gases are together known as NOx. When these guys are given out by vehicles, this guy goes to the stratosphere and breaks down ozone into, when the NOx goes to troposphere, the atmospheric oxygen is getting disturbed by UV light radiation and the presence of nitrogen dioxide. In the troposphere, due to the UV light presence, when UV light is exposed to NO2, it becomes NO plus O. This superoxide radical, it reacts with the tropospheric oxygen to give out ozone. This is what is causing ozone to pile up in the troposphere, becoming a greenhouse gas and also a pollutant. The next character in our story is chlorofluorocarbon. Chlorofluorocarbon is entirely a man-made phenomenon. It is entirely an anthropogenic phenomenon caused by human-made substances like refrigerants, flame retardants, etc. So all our refrigerants give out CFC. This was the case before the 1980s. In the 1980s, Montreal Protocol came into effect. According to the Montreal Protocol, CFC was wiped out from the refrigerants, coolants, and flame retardants. And instead of CFC, HCFC was added to flame retardants, refrigerants, and coolants. So HCFC came into limelight after 2000s, after 1990s. Okay. However, later it was found that HCFCs also caused global warming. And it was added to potential global warming gases, greenhouse gases. HCFC means hydrochlorofluorocarbons. Okay. So after HCFC was found to be a potential greenhouse gas, now after 2010, during that time, HFC came into effect. So basically at present, both CFC and HCFC is substituted by HFC. CFC became HCFC, and after that now it is substituted by hydrofluorocarbons in flame retardants, refrigerants and coolants. HFC, hydrofluorocarbons, has comparatively very less global warming potential than HCFC and CFC. This brings us to our next topic, which is known as global warming potential. Before understanding global warming potential, you have to take into consideration two aspects, two characteristics of gases. Gases, like greenhouse gases, has a residence time in the atmosphere. Okay, for CO2, this residence time is variable. Okay, however, for methane, it is 12 years. For N2O, it is 120 years. For CFC, 2. CFC, chlorofluorocarbons, are of many types. Okay, CFC 11 is there, CFC 12 is there, CFC 121 is there. Okay, so in that CFC 12 has a residence time of about 1600 years, and HCFC has comparatively less global warming potential, residence time than CFC. It is 12 years. When we consider the phenomenon of global warming potential, the idea of global warming potential, residence time of individual gases is of particular importance. Besides the residence time, another idea related to global warming potential is RIRF. RIRF simply means relative instantaneous radiative force. What does this idea indicate? Relative instantaneous radiative forcing of a gas indicates the potential of a gas to create global warming. Relative instantaneous radiative forcing, or RIRF, simply means the amount of climate change, the amount of warming that an incremental addition of a particular gas to the atmosphere can cause to the total radiative forcing. What is radiative forcing? Radiative forcing is the absorption of infrared radiation. In our last video, we have discussed what greenhouse gases do. Greenhouse gases, when the earth emits IR radiation, they absorb it, and this absorption causes greenhouse effect and global warming. So, when, for example, CO2, 1 gram of CO2 is emitted by a vehicle. When it runs for 1 kilometer, it emits 1 gram CO2. Just imagine. Okay. So, when this vehicle emits CO2, 1 gram of CO2 to troposphere, okay, troposphere, it increases temperature of 1 degree Celsius. Just imagine, okay, this is not the actual quantity. I just want you to understand the concept of radiative forcing and RIR, related instantaneous radiative forcing. Okay. Consider this as a vehicle. When it goes for 1 kilometer, it emits a carbon dioxide of 1 gram. And this 1 gram of carbon dioxide causes an increase in temperature of 1 degree Celsius. This idea is called as relative instantaneous radiative forcing. Okay. And global warming potential of a gas, which is otherwise known as GWP, of a gas is relative of RIRF, RF, and residence time of the gas. Global warming potential, when we calculate it by RIRF and residence time, gives out the global warming potential of a particular quantity of gas. And global warming potential is always carried out, global warming potential is always determined in relation to carbon dioxide. Okay, so when we are comparing the global warming potential of all greenhouse gases relative to carbon dioxide, the global warming potential of carbon dioxide is 1. Okay? Oh. So that will be all for today's video. The remaining concepts we will discuss about in our next video. In the meantime, take care. Bye.